Okay, so today I'll give you some additional thing, right, of some built-in functions, and I also show you how to import any files from external drive, right? These are the topic I'll cover today. So let's start first the built-in function in R. So I'll show you a function of different type, the functions that used for processing of character data or a string. Then I'll show you some mathematical function, and then at the end I'll show you the functions related to statistics. Okay, after that I'll show you how to import a file using this read.table functions, and then these are basically a function built in R, right? This is a part of a base R. And then in case of a large function, in case of a large file, how to import a file. So I can also show you reading or importing large data with read.table. So in case of large data, there may be an issue of some lag, right? But large means, again, same thing in the term of petabyte or terabyte, okay, and not GB, right? So they created additional add-ons package, and that is called readr. So I'll show you that part at the end, right? So readr is a package. This is a part of advanced R, and this can import or read a large files quickly. Okay, there are some additional feature here, and in between I'll show you the memory requirement, right? So if we are importing any files or if you are reading any files from external drive, your RAM should have some sufficient space. Okay, so this is basically for a large data set. In case of data sets that we generally use in a clinical testing, there should not be any problem. Okay, so I'll show you the calculation of this memory requirement for certain files as a base, as just a rough calculations, and these are basically required in case of a very large file. Why this is important? Because if your RAM does not have a sufficient space, right, it will basically slows down your system and it will slows down other thing that you are doing. For example, right now I'm just recording the screen. Okay, so suppose I'll import a very big file and it doesn't have sufficient space in the RAM. So what this does, it will basically compromise the other tasks that I'm doing currently, right? So that's why we should have some rough idea, okay, how memory calculations, right, how we do the memory calculations, and you should be very careful whenever you are importing a very large file. Okay, so these are the things I'll cover today. So let's jump to the RStudio. Okay, so I can again clean all the stuff from here, and then I'll set the working directory to this folder September, and I'll set the working directory here, material, where is it? Yeah, so I'll set at this location. Why? Because I'll have to import these datasets. Okay, so let me change this slash. What I can do, the efficient way is you can select this whole thing, then Control F, and then here you can just replace the backward slash to a forward.
Sir, what is this for, like control plus R? Like
Control plus R is the command that we generally use for running the particular code chunk. For example, I want to run this, so I can either use this run button or Control plus R. Okay.
But sir, we use, like, in RStudio we use control enter, right?
Control plus R is the command that we use in R. For example, yeah. So this is the R. R 4.4.1. So if you want to run anything in R, so you'll have to use Control plus R. And if you're if you are using RStudio, you'll have to use Control Enter. Sorry. Okay. So now I'll set the working directory here. Let me check. Yeah, this is okay. And now I'll utilize this location, because here, if you notice, we have a bunch of datasets, a bunch of files that I'll utilize in this session. Okay. So first of all, some built-in function. So first of all, I'll cover the built-in function that are of string kind, right? The function that is used to process the string. So let me create a string. Welcome to Great Online Training, without any space, right? This I created intentionally, right? So we have a function substr, As name suggests, this will basically subset or extract the part of the character from the main character vector. Okay, so how we have to use? We'll have to use substr, and here we'll have to specify the parent character vector or original character vector, and then we can specify here start position and end position. Based on this position, it will try to extract the part of that string. Okay, for example, let me run. So I can use substr. I can specify a here because a is our main vector, and I'm specifying here 2 comma 8. So 2 is a start position and 8 is our end position. Okay, and here I have not used the explicit expression that this function has. For example, what is the explicit expression? If you want to use this way, right? Substr a, then start is equal to 2, stop is equal to 8. So this is called exact referencing, and here this is an example of positional referencing, because here we are not using the keyword that this function has. I'm just specifying the values for a particular key. So it will take start as 2, stop at 8, right? And it will try to extract from the first position to 8th position, right? So let me run this and show you. And this is the part from start 2, right? So 2 is here and 8 ends at t. And if you run this one also, you'll get the same result. There is no difference, but I recommend, right? So if you're at the very beginning, right, try to use the complete expression or exact referencing for processing any function. Okay, if you're using anything, try to use this one. And I also recommend one thing. So when you are practicing, right, because RStudio can provide the maybe a suggestion for a function. What this means, for example, I want to use substr. So if I just write a part of that, it can give, right, the whole function, and also give an idea about what this function, what are the argument of this function. So so if you use this way, right, you don't have to remember, you don't have to recall what are the argument that particular function has. But on the other hand, if you use r, so this is not an efficient way, but at the very beginning I recommend using r, because you can very easily recall or very easily remember the syntax of a particular function. For example, here I can create again a string clinical r class, right? And then I can use substr. So here it will not give auto suggestion for the keyword or function, so I'll have to write the complete function, right? So this is a good idea if we start using this r at the very beginning, right? So I can use 2 here and end as 8. Yeah, it will extract a part of the string. And here for running the script, you'll have to use control r. Oh, sorry, start and stop. Yeah, so this will extract a part of that. So if you are very basic level, right, and if you want to make sure that you have knowledge of all the functions, try to use r at the very beginning, because it will not give auto suggestion of a function or a keyword, and you can very easily do a practice, right? So this is maybe some challenging task, right, but you can use this r. Okay, let me cover another function. Yeah, this is a string x create online training, and we can convert to a lowercase uppercase using the function. So we have a base function to lower. As name suggests, this will convert to a lowercase. Yeah, here. Similarly, we have a function to upper, so it can convert. So if you notice now, right now we have in lowercase, and if you use to upper, it will convert to an uppercase. Okay, great online training. But we don't have any functions for the prop case or a title case in base R. And for that, you'll have to install and load this string R package, right? So let me install. Very quick. Yeah, this is installed, and I can comment that line because I don't want to install again and again. And I'll just load. And here we have function str to lower, so it will convert to lowercase. Okay, then here str to upper, it will basically convert to an uppercase. So let me show you. This has the same result as of 2 lower and 2 upper. Okay, so you can check. Then again we have two other thing. One is str to title, right? So it will basically converts the alphabet in such a way that it will basically have the first letter of each word as a capital letter. Okay, so this is called title. It will convert the first letter of each word into a capital letter. So if you notice, G is in capital, O is in capital, and also T is in capital. This is called a title case. And then prop case, this is very easy. The first letter of the whole character vector, right, is in uppercase, and all are in lowercase. Okay, so these are the function there. Yeah, so we have, so you can use either base R, or you can use a string R functionality for converting anything into uppercase or a lowercase. Okay, so I'll pause here. Any question? Hope this is okay to everyone. Yes, Razi, I guess your mic is on. Any question? Razi? Sorry. Okay. Next, I can create, I can use, once again, this way, str underscore sub. This is again a function that is a part of string R. Okay. So all the functions that are a part of string R starts this str. So this is just a prefix we have for all the function that is a part of a string R, right? And we can use also this str underscore sub for subsetting, right? So this is similar to substr function, but substr is a part of base, and here str underscore sub is a part of a stringer. How can you identify that part? So you can just write sub str, okay, and here it will give information inside the curly braces. So this is a package name, all right. Similarly here, if I write str underscore sub, so sorry, sub. So you can notice on the right hand side, it is giving information inside the curly braces, and this is the package name. So it is coming from this string R package. Okay, so you can very easily yeah, understand from where it is coming. Okay, the next thing is I can create a data frame. So this is just for a single vector, right? But how we can convert those into lowercase, uppercase in case of a data frame. So first of all, you can create a data frame. So here we have a data frame, data.frame. Here we have a bunch of names. Yeah. And now what I can do, I can either convert here itself, right? So you can notice I used str2 upper at the dataset preparation stage. So you can do that, or you can use a function outside, right, the data frame premises. So let me first create the data frame. Here we have x, and if you notice x, we have two variables. One is id, the second is name, and all the names whatever we have, these are in some are in prop case, some are in yeah, so we just have two letters, that's why this is in uppercase. So we can very easily convert to an upper, lower, or any cases, right? The next the main important part is, suppose I want to create a new variable out of a case. So what I can do, I can just specify here the object name x dollar symbol and then variable, right? So it will create a new variable here in this data frame x. So right now x has two variable, right? But you can create other variables just applying the functions, right? So right now three, you can very easily check name and name in lowercase, right? So ideally I have to use here str to lower, because so that I can very easily understand, because I created a variable name in lowercase. That's why I'll just try to preserve that structure. Here I'm using str to upper, and here I'm just specifying the variable in uppercase. Okay, so to create one more variable, and then we can use again the other thing, prop, sorry, not prop case, it should be sentence case. Okay, and let me just change the variable name. Yeah, so we already have here the prop is structure. So what I can do, I can just create a name one. Okay, we can very easily verify. So you can notice this is in lowercase, name in then uppercase, and then here we have prop case. You can notice the difference here. RK, R is capital, K is small. Here both are capital, both are small. Okay, so in this way you can create a variable. You can add a new variable. You can create additional variable in the data frame. You just have to use this structure. First, you'll have to specify the data frame name, dollar symbol, and the new variable. And whatever thing that we are doing on the right hand side, this is basically you are processing a particular variable, right? You are applying a function on a particular column. Okay, so this is one part. Sometimes, suppose we have a data frame, and over there we have a variable name in sometimes we have variable in lowercase, sometimes in prop case, then uppercase, right? For example, here if I use call name, I intentionally created that, but ideally we should have some homogeneous structures. For example, if I use call name, right? If you notice, we have variable in prop case, then lowercase, then uppercase, right? I created intentionally just to relate this function, right? But sometimes in the data frame we may have these situations, and then what we have to do, we just have to harmonize. We can either convert in lowercase or uppercase. I recommend, so whenever you're using R, so try to create the variable name in lowercase so that you don't have to use a shift key or caps lock key again and again, right? This is an efficient way. So how we can convert? Well, first use here a str to lower, a to lower, right? You can use anything, str to lower on top of this call name. So what this does, it basically converts all the variable in a lower case, right? You notice this is the thing. And next, what I can do, if you want to change, right? So I can just reassign this whole thing. Yeah, I can reassign, and where I'll reassign, I'll reassign to a call names of X. Okay, and if I write now, just check the call name, all must have the same data type, right? All must have either lowercase or uppercase. So right now here I'm using str to lower, so it will have lowercase. Okay, so this is the thing. And if you notice, because the inherent structure is same, so that's why it added here a dummy suffix .1 .2 just to distinguish, because we already have a name variable here in this parent dataset, right? So we cannot have a same column name, right? Or in a dataset, so that's why it's just added as suffix, okay, for us just to distinguish. Okay, and then you can very easily extract. For example, I need the variable, so here we have, okay, and we also have the .1, so we can very easily use and harmonize. This is a very useful function for harmonizing the variables or column names in a data frame. Okay, so you can import any files from external drive, and then you can harmonize so that you don't have to use different cases every time, right? You can use either lowercase and uppercase, and I recommend lowercase is a preferred structure. Okay, I'll pause here. Any question, anybody on this?
Call names str to lower, call names it has changed all that to lowercase, right?
Correct.
So how does it change the into character type automatically?
No, it will not change the data type of that variable. It will only modify the variable name, right? It will not do anything for the data type. Yeah.
Lastly, you like when you are telling, like all are same data type you have shown, right?
Yeah. So all
it got distinguished only by the name, like name.1, name.2, name.
Correct. So all must have the same time. Yeah, it will not do anything for the data. It's data type as such, right? You can notice all are character. It just modify the variable name, right? That's all. So we are just modifying the column names or variable name. Okay. Yeah. Oh, sorry. Okay.
Ranjit, it's just similar to options valid var name equal to uppercase in the SAS.
Correct.
Okay.
Yeah. Okay, next I'll show you some additional function. For example, here we have a string z. We have 4 element a b c d in lowercase, a b c d in abc in lowercase, then a b c d in uppercase, and then a to h, right, in lowercase. So let me run this, and here we have z. Then suppose I want to identify some pattern, right? So I can specify additional vector pat, and here I use abc. So we have a function grep, right? grep. This basically helps in searching a particular pattern in a character vector. Okay, so how we can do, this is the structure of this function. We'll have to use grep. Here we'll have to specify the pattern. Here we'll have to use the parent vector, and then we have a function or keyword ignore.case is equal to true or false. So what this ignore.case does, it will basically allow us some kinds of functionality, and we can use ignore case is equal to false or ignore case is equal to true. When you use ignore case is equal to false, that means it will consider the case while searching for a particular pattern. Okay, so that means ignore case is equal to false. That means you are not ignoring the cases, right? Whenever you write ignore dot case is equal to true, that means you are basically giving an information that don't consider the case. Okay, ignore the case. So what this means, so for example, here we have a grep function. So what this does, it will basically provides the indexes for the match. Okay, so if I run this, it will give you here a values. So 1, 2, and 4. So what this means, that means it is saying, say, in the parent vector we have a match at first position, we have a match at second position, and also we have a match at fourth position. It is not giving the match for the third position. By because the cases are different. Here we have abcd in uppercase, whereas I'm looking for a pattern in lowercase. That's why it was not giving anything, right, for the third element. Okay, whereas if I just write ignore.case is equal to true, it'll give information. It will also highlight, right, the match for the third, because if we ignore the cases, so these two are same, right? abcd in uppercase and abcd in lowercase, right? So we have the match here if we ignore the case, right? So this is the way how this works. Similarly, we have a sum function, sum. This will basically allow us in replacing some character or string. Okay, so let me do that. Let me show you the structure. Here also we have to use pattern first and replacement, and here we'll have to use the parent vector, and again ignore.case is equal to true and false, right? So let me show you. So here we have A1. This is SAS programming. Then what I want to do, I want to replace, this is just an example. Every programming is a very have some additional or unique feature. So this is just example. Yeah. So a pattern is equal to SAS, replacement is equal to R, and here we are. Here I'm specifying X is equal to A1 because A1 is our parent character vector. Yeah. So if I run this, what this does, it will basically replace the text SAS with the text R. Similarly, we can do in a positional way, right? We don't have to specify this pattern is equal to or replacement is equal to. We can specify directly. The first is for the pattern and second is for the replacement. So we can replace SAS with Ruby. Ruby is another programming language. Here we have, yeah. So this is the way how this works. You can do the replacement for a particular, particular string or character vector. Okay. Yeah. Any question?
Ranjit, I have a question. So how can we identify the substring and then the sub?
Yeah, so you'll have to check, right? So this is the way how we'll pass, right? So whatever the thing that you want to replace, you'll have to specify here. This is the way this works. You should have some.
But both are same, right? Can you scroll a little bit up?
Mm-hmm. Where both are same? Which line number you're referring?
A little bit up. The substring thing you were explaining, right? So that is Yeah, substring.
Yeah, you are here at line number 15, right?
Okay, so that is substr, and this is just sub.
Correct.
Oh, okay. So what? So what does this sub does? It's just replace.
Yeah, so here I use sub is equal to replace a particular vector or a string. So here we are just doing replacement of a text. We are replacing SAS with R. This is a different function, and substr is a different function, str underscore sub. So there is a similarity with str underscore sub and substr, right? Substr is just to extract a part of that. So subset, maybe you can remember, this will basically do the subset from a string vector or a string.
Okay.
Yeah, and then you can use str underscore
this
sub.
Is substitute.
Yeah, and then this will substitute or replace.
Okay.
Yeah.
So all these are in the base package, or the other one you just downloaded?
No. So here
This is the
package name. I already specified, right? So all the things that we have.
these. Okay, so all these functions are inbuilt in stringr library.
Not all these functions. All these functions that starts with str, that is a part of a stringr package, right? You can very easily identify, right? You just have to write str, right? And all the functions, right? You can notice on the right hand side we have a curly braces and we have the function name. Okay. Whenever we have string r, so these are the functions that is a part of a string r package, right? So suppose I write here.
Okay, so all these are in the stringr that starts with str underscore.
Correct. And
and how about the sub?
Sub is also a part of this, right? Sub, if we just write.
Base.
Sub is a part of base, right? So here I'm just covering str underscore sub. This is a part of base. We also have function in string r that is called str underscore sub. This also does This also does
same.
Yeah, correct.
Same.
Yeah, it will also extract the part of the string, right? So it will do the subsetting, not the replacement, right? For example, here I cover str underscore sub.
Mm-hmm.
In string r, we have a function named str underscore replace. Yeah, so we have that. This is a very user-friendly function. You don't have to remember, because replace means it will do the replacement of a certain string r. Better.
Okay, not the str underscore sub. We do not have str underscore sub.
We have that, right? So we have that here. I already covered, right?
Where is the
here? Right, line number 84. str underscore sub. This is a part of a function that is in a string r package, right?
Okay. So now, you are covering both the packages, and the functions that are present in the base, and then the string r.
Correct.
Simultaneously. Okay. Yeah, got it. Thank you. Sorry for the confusion.
No. It's okay. Just be there.
Hi, sir. Sir, I have one question. So we are using str underscore to underscore lower for changing the column name.
Correct.
But if we want to change observation, like upcase and lowercase, like in case of observation, like
so
names.
here, I changed the observation, right? If I show you the x.
Okay, maybe I missed,
here I just changed the observation. This is just a special feature I just showed.
Yeah. I missed that. Yeah.
Okay. I'll pause here because I don't know why you're asking. Yeah. So maybe you can ask me questions here. The thing that I covered so far. Anybody? Any follow-up question? Anything?
Hi Ranjit. Sub is like tran word, right? Works like tran word.
Correct.
Function.
Yeah, correct.
Thanks.
No, it's okay. Anybody? Riaz, Rashid, Ramya. Sorry to putting a spot. Shilpa, Yamni. Anything?
Hi Ranjit.
Yeah, please.
So just now we have seen in the string package we have replace option, right? str replace.
Correct.
And this is a sub function. How does these two are different? That is also replacing a string.
Correct.
And it is replacing them.
So this is a sub is a part of a baser function, and str underscore replace is a part of stringer. Yeah. So you just have to type here.
Okay.
Yeah, you just write here sub.
Anything we can use, right?
Yeah, anything you can use, right? So whenever we have a possibility, try to use the function that is a part of some advanced package. Why? Because that is efficient and that have some additional feature. You'll have to cross compare. Okay. But whenever we have
So we have to use advanced.
Correct, because that have some additional feature and those are efficient.
Okay.
Yeah.
Thank you.
How do we know that it is an advanced package?
So if that is not a part of base, so that means that is advanced.
It's an advanced.
Correct.
Oh, okay. Okay. Thank you.
Okay. Anybody, any thoughts, question? Okay. So paste, I already cover. Maybe I can cover once again. So this allows us to concatenate or combine two or more than two string. So you can use paste, and here you can combine. You can write text. I'm just writing 3 text to basically combine these 3. Okay. There is an inherent structure. If you notice, by default, it added a space between the words, right? So because the space function, if I show you the help, this function has a default structure, right? Paste, and if you notice, separator is equal to space, right? So this is a blank space. This is a default argument, right? So that's why it'll add a default as a space. But we have also a way we can specify some other separator, right? So for example, if you want to add additional separator, different separator, you can specify here. I will combine A and B with separator underscore. Okay. Similarly, we have a paste 0 function. That function does not have any keyword for the separator. It will just combine as it is without any space. But if you want to add some additional separator in between, what you have to do, you just have to add with as a additional character, right? So here I'm just adding underscore in between so that it will combine A and B with underscore in between, right? Here we have. So paste 0 does not have any functionality for the separator. If you want to add the separator, you will have to add as explicit string or explicit character. Similarly, again, here we have a bunch of example, right? So you can just run and then check. Okay, now I'll move to str split function. So as name suggests, this basically split the character vector or a string. So let me show you. I can print here y. Y is our great online training, right? I created here at the line number, so I created here at the line number 75. Okay, so now I'll use that and I'll split. So this is again a part of base R function, right? So you can just write str split, right? You can notice this is a part of a base. We also have same function, similar kinds of function under the stringer. So you can use either the base or a string. Okay, let me show you this one. So you'll have to specify first the vector you want to split, and you'll have to specify the splitting argument. So I'm specifying without anything. So I'm just adding quote without anything inside, right? So what this does, it will basically split everything at the correct alphabets level, right? So what this means, let me show you. So our parent vector y as this great online training, and if I use this split with the nothing inside, right? So what this does, it will basically split this whole thing at the alphabets level, right? And now this is basically a list. You can notice this 2 big bracket. This is an indication that this is creating a list object, and then you can extract right the same way. Suppose I want to extract this second letter. So what I have to do, I just have to specify this object name x, then double big bracket 1, and then I can use again a single big bracket 2 for extracting this r. And here I just use the same thing. We can also split with the space. For example, in the great online training, we have spaces at here, right, between great and online, and also we have a space at right between online and training. So you can utilize that space, and you can also split this whole thing. So in that case, it will basically break the whole thing in 3 parts. Okay, the create, online, and training. The difference between this line number 91 and line number 95 is here we don't have a space right inside the split. So it will basically break all the thing at the alphabets level, right? But here I specify the space. That means it will basically break right based on the space as a separator, right? So that's why we have here 3 words and we can extract it. Okay, suppose I want to extract this second one, so I can just write here double big bracket 1 because this is at the compartment number 1, and this online is at the second position. That's why I'll have to use 2, because if you just extract this compartment, so this all 3 are a vector structure, right? So that's why I have to use 2, and I can extract. Similarly, I can extract third, right, and so on. So maybe you can try the other thing. Okay, suppose I want to extract 2, right, 2 later, for example, online and training together. So what I can do, I can specify the position for this online and position for the training. Position for the online is 2, right, this way, and position for the training is 3. So what I can do, I can combine 2 and 3 at the very end, right? And this is the way how we can extract 2 later in one go. So you can use this structure, or because I already I splitted this thing where it is. Okay, let me split with the space, right? So if I do that, it will basically break at the word label, right? And now I can extract. So here, this is the object we have, right? So I split it and I store here in X. So I can use very easily X, right? And then this structure, because this is at the compartment number 1. And then we can use 2 and 3 for extracting the online training. Okay, so these are the function we have under this stringer. Any question before I move to the mathematical function?
Yeah, Ranjit, I have a question here.
Sure, please.
So after split, STR split, you mentioned Y vector name and the separator. And after that, you mentioned like 1 and 1. What like it means, like it is for only for reference, or yeah, that one.
Yeah, so whenever you use this str split function, what this does, it will basically create a list object, right? And you can very easily identify from here. So for example, the first, you can notice this is the double big bracket. Whenever you have a double big bracket, that is just an indication that whatever the object that this function is creating is of a list kind, right? And for extracting that or maybe for extracting any element from that list, you'll have to use this double big bracket notation. So that's why I'm using here double big bracket 1, because all the alphabets, right, these are at the compartment number 1, right? So I have to use this
Okay.
yeah. And then for example, I want this R. So what I can do, I can use 2. So let me just use here. Can you notice? This is the result. So this double big bracket, 1 is for compartment, because we just have a single compartment, right? And then single big bracket, because if we just extract a compartment, right, whatever the element that we have is in vector form, and you can use single big bracket for extracting the element from a vector. Okay, hope this makes sense.
Yeah, that's
Perfect.
So STR split is a base R function, or
Right, this is a base R function.
base R.
Correct.
Okay.
Hi, question.
Yeah, please.
Would you use the same function if you need to replace like a word, like the online, if you want to replace the online to a different word? Would you use the same function?
You can do that this way, but the other function, for example, str underscore replace, that is a part of maybe string package, that is much more efficient, because whenever you are creating anything as a list, right, list is not efficient, right, in processing the data. So so we generally have to avoid that structuring. Okay, so we just have to choose a route where function does not create the result in terms of list. Okay, you can use here also, you can very easily replace. For example, what I can do, let me do that. Let me show you. So here, let me write. So I have X X is this one. Suppose I want to replace this online with offline, right? So what I can do, I can first extract that. So double big bracket 1 and then a single big bracket 2. It will extract, and then I can do a assignment. Suppose I'll write here X. Yeah, so I can assign here. I can assign this whole thing as offline. So what we are doing, we are first extracting the online from here from this syntax, and then I'm assigning to offline. So what this does will be, it will basically replace. Okay, so if I print this X, it'll have great offline training. Okay, so this is the way how this works. So you can do that replacement, right? You can do maybe replacement this way, but whenever you'll create anything, whenever functions create a list object, that is not efficient, right? So we should avoid that part. Okay, hope this makes sense.
Yeah, got it.
Perfect. So you can use either str underscore replace, and you can do that replacement.
Ranjit, is it similar to scan function of the SAS?
Yeah, you can think of this is similar. Yeah.
Then could you please show us in the particular variable where we would have in unique subject ID, we would have this subject ID and site ID.
No.
If I just want to...
No, it is not working in that way, right? We are basically here, this basically splitting the thing, right? It is basically splitting the thing, right? So we are not, this function is not used for replacement purposes. I just showed an example how we can do the replacement, but this function is just used to separate the thing, right? So for example, you have a very big sentence. What you can do, you can separate, right? And then you can do the replacement. This is also one of the way. But why we don't use this str split structure? Because very often, because this is creating a list. A list is not efficient. Yeah.
Okay.
Yeah. So we can use other function. For example, you can use str underscore replace, str underscore maybe find. Okay. Str underscore extract. Yeah. So there are a whole lot of functions. I'll show you at the end, right? All the functionality that is a part of our package.
Sure.
Yeah. Anybody, any thoughts, question, anything? Okay, so there are some basic mathematical functions we generally use in a very right, in a regular way, right? Type of these I already cover. Okay, so first is ceiling. It basically returns the smallest integer which is larger than or equal to x. So you can remember this is a word, floor and ceiling, right? So ceiling is at the top, right? So that's why it will basically return the smallest integer which is larger than or equal to x. So I'm just using x here as 2.01. If you notice, we have a decimal component 0.1. So that's why it will basically provide a 3 as an answer when I use ceiling. When I use floor, it will provide a 2. Why? Because this is the inherent structure, how this works. Okay, so it will basically return the largest integer which is smaller than or equal to x. Okay, then square root, these are very simple thing. One thing I just want to emphasize here, so square root, this will do the square root of the thing, exponent, it will basically raise to the power x, exp to the power x. Yeah, here this log is a log with base e, right? This is called natural log, and here we have a function with base 10, right? So sometimes whenever you are converting to logarithmic scale, so we generally use log with base e, right? This natural log. But sometimes there may be some specifications, right? This is specifically in analysis of PK or PD data, right? Immunogenicity related data, right? Or antibodies related data. So whenever you are trying to convert on a logarithmic scale, try to use this log with base e, okay? Natural log. Don't use this log base 10. This is another way of converting in the scale of logarithmic scale in the unit of base 10. But we generally use this natural log, okay, because these are the standard. Then other things, sine, cos, right? All trigonometric function we have right here. You can utilize. Generally in the clinical translating, we generally don't use the sine and cos, right? But I added here. And then the next thing is how to raise a power on a certain function. So we just have to use this caret symbol. This is called caret, and you can use power. Okay, and here we have. Suppose here we have a number 1. Let me use some other number. Maybe I can use 3. Okay, this is in character, right? Suppose I want to convert to I just have to evaluate the square root. The first thing is we'll have to convert that number into a numeric data. So I can use as.numeric, and then I'll have to use sqrt on top of that. Okay, so this is the way it will basically function from inside to outside. So first it will evaluate this one, and then it will evaluate this sqrt. Okay, so here we have. Then the next is some statistical function. We generally cover this very often because in the part 2 is basically for all the statistical functions, right? This is the numeric vector I'm using here. Bunch of decimal components, and one value is of negative, right? Minus 4.0127. Okay, so first function is trunc C. So this is not a round. This is a function we generally don't use. Okay, why? Because what this does, it will basically ignore the decimal component. It will basically preserve that integer. Okay, so you can notice it altogether drop the decimal component from the number, right? Without taking care of the decimal part, right? It basically directly drop. Okay, so this is the thing. Sometimes you can think of this as an integer. Suppose you want to extract the integer component from the number, you can use this trunc C, but generally the decimal is also some having some informations. That's why we generally don't drop, but sometimes this may be useful, so that's why I just added here. Okay, and very useful function is round. We can do the rounding up to 2 decimal, 3 decimal, right? Based on our requirement. It will basically do the rounding, taking care of the decimal component, right? You can do a rounding up to a 0 digit. So this is maybe exact referencing or exact syntax, or we can just write 0, 1, 2. Okay, then here is just the main statistical function, sum of x. What this does, it basically add all the element that this vector has. Okay, here we have one values as negative, so it will add all, right, and it will provide the result. Then sometimes we need to convert all the values in absolute term. Absolute means what? Sometimes we have positive, sometimes we have negative values. Suppose I'm interested only in the magnitude. That means I can remove the sign using this ABS function. So it will basically have all the values, right? So you can notice this second last values. Here we have minus 4.0127 in the parent vector x. But when I use ABS of x, it will basically convert that into a positive number. Okay, it's dropped that negative sign. So this is the meaning of absolute. Similarly, the very basic mean, you can extract the minimum values, maximum values, mean, right? Mean is basically sum of number divided by the number of number. Okay, you can very easily validate. So I already evaluated the sum here. I can evaluate the sum first, and then I can divide by a length of x. So here we have how many number? We have basically 1, 2, 3, 4, 5, 6. So this length of x is will basically return 6 as a value, and I can divide the sum by 6, and it will be equal to the mean that we are getting out of this mean function, right? And I can notice both are same. So you can do these kinds of validations. Okay. The next is here. I have here a character, a numeric vector x. Okay. So we have 3 values, 1, 2, and NA. So in the third position we have NA. Suppose I want to know how many NAs we have in a vector, right? So what I can do, let me just use, maybe I can add here. I can show you that functionality here. So what I can do, I can just use is.na, and I can use x here. So what this does, it will basically highlight the NA in the form of true, and all the position, right, other than all the values other than false, it will basically tag with false. All the values other than NA, it will tag with false, right? So this is the functionality. Okay, then what I can do, I can run a sum on top of this is.na. Yeah,
Any small question here.
yeah, please.
That whenever the is.na will come, right, it will reveal actual result, right? Whether it is true or false, right?
Correct. It will provide.
Is
Yeah, so you are asking question, is a particular thing is NA, right? So it will provide the result in
okay.
terms of a logical data type, true or false.
Oh,
Okay.
okay.
Yeah.
Got it.
And yeah, so I also mentioned, right, I guess in some classes, that it basically preserve, right, it basically store true as 1 and false as 0. Okay, so when I use some function on top of that, what this does, it will basically counts the true. Okay, and here how many trues we have? We just have a single true. So how many missings we have? We just have one missing values in x. So you can use this function for counting the missing n. Okay, then sometimes we'll have to also evaluate the non-missing. So what you can do, you can just negate, use this exclamation symbol, and what this does, let me just run this part. Yeah, it will give 2. Sorry, let me just write this one by one. So what I'm doing, I'm just using is.na, then I'm passing this x. So it will basically tag na with true. Suppose I negate, what this means, I'll just negate this exclamation symbol. So it will basically switch this tagging, right? So it will tag na with false and non-missing values as true. Okay, so it will tag in a different way. So you can notice at the position of false we are having true. Okay, at the position of true we are having here false. That means we have true indicated for all non-missing values, right? This is the thing I want, and then I can use a sum function on top of that for counting how many non-missing values, right? So I can use a sum on top of that and will provide there are 2 non-missing values, and these are the maybe additional way of counting how many missings and how many non-missings we have for a vector x. Okay, hope this makes sense.
Yeah.
Okay, anybody, any question? Okay, so let me cover the other part. So we can also evaluate the median. Median is basically a point that split the data into 2 equal halves. Okay, so here we have x vector and I can evaluate the median. Okay, so let me, yeah, so let me verify. So here we have, I'm just defining this 5 values, 1, 2, 4, 5, 7. And if you notice, I just, so for example, if you want to evaluate the median, what you have to do, median is basically a value that splits the data into equal halves. So you can either rearrange the values in ascending or descending order, and you'll have to choose the middle one, right? So here we have 5 values, 1, 2, 4, 5, 7, and I already sorted in ascending order. Okay, so what I can do, I can choose the middle value. So I can cancel one from here, I can cancel one from the end, right? We just have 3. Then again I can cancel this 2 from the beginning and 5 from the end. So we just have a single values, 4 is in the middle, and this is our median, right? So in case of odd number of values, we can very easily get an idea about the median. But what about in case of an even number of values? Okay, here we have 6 values. In the same way, you can just sort the data. You'll just have to arrange in either descending or ascending order. I already arranged, right? Then I can cancel one from the beginning, one from the end, right? We just have here 4 values. Again, I can cancel 2 from the beginning and 7 right from the end. So we just have these 2. So median will lies between these 2 values, 4 and 5. So what I can do here, I can just add 4 and 5. So this is 9, and you can divide 9 by 2. So we'll get a median as 4.5, right? And this is the result we have. Okay, so this is the way how this works. Let me show you. So I'm just storing a num having the same number 5, and I can split the length. We have 5 values here. I can evaluate the median, and you can notice it is giving the same, right? 4. And I also evaluate it manually, right? This is also 4. Similarly, we can check for the even number of data. This is again giving 4.5. So this is the way how this works. It basically provides the median values, okay, and that we have to keep in mind. Okay, the next thing is, sometimes in the vector, right, we may have NAs. For example, here x1, we have NAs at the last position. So suppose I evaluate the mean, right, or any statistical function, it will basically returns NA. Why? Because if we add anything to NA, it will return NA. If you multiply anything with NA, you'll get NA, right? So if you do any operations, you'll get NA at the end. So this is the problem with R, right? So how we can resolve that? You have a function or keyword na.rm is equal to true. So what this does, it will basically ignore that NA and will try to evaluate the mean for the rest of the non-missing values. Okay, so if I run this, here we have the result 2.5, and 2.5 is a mean of a first 4 non-missing values. It will basically drop this NA. Okay, and you can very easily check right this way how many. Yeah, I'll get again this 2.7, 2.5. Okay, this is again the same thing. So this is basically provides how many non-missing values we have, right? And then here I'm just dividing the sum but number of non-missing values, right? And you can verify that. And if you use mean without na.rm is equal to true, it will not provide any meaningful answer. It will return any. Okay. So then again here some bunch of evaluation for standard deviations. Let me show you. So here we have x, then I can evaluate mean, then we can evaluate the deviation. What deviations? We just have to subtract each values, right? We'll have to subtract mean from each value. So mean is 3.87, right? So we just have this thing, right? I can copy and I can paste. So I'm just subtracting, so I can use this structure. So x minus 3.837283. So what this does, it will basically subtract 3.837283 from each number, right, one by one, and will create a vector with the name deviation. And here we have. Then what I can do, if I just add, right, some positive and negative values, right, cancel each other and not get a meaningful answer. So what we can do the square, right? What the square does, it will basically remove the sign, and also it will basically magnify the quantity, because if you do the square of 2, you'll get 4. If you do the square of 3, you'll get 9. That means it will basically magnifying the deviations. Okay, so you're magnifying the deviations. This is one advantage. And then it will basically resolving the issue of positive and negative value canceling each other, right? So when I do the deviation squares, so it do the both thing, and then I can use the sum function and I can divide by 5. So this is our sum of a square, right? And then because I use a square at the very beginning, so I'll have to use a square root so that I can get the answer in the same unit as of the original vector x. Okay, because if you do the square, so for example, you have a height 170 centimeter. If you do the square, you'll get the values, and the unit also will be in the unit square, centimeter square. For example, if you have values of 4 meter, if you just do the square, you'll get 16 meter square, right? So it will also basically influence the unit part, right? And because of that, we'll do the square root just to get the answer in the same unit, right? So here, this is our standard deviation. This is 4.464267, right? And I can evaluate this ST with this standard deviation with this ST function. You'll get the same answer. Okay, so this is the way how this works. So, and here if you notice, I divided with 5. Why not 6? Because I'm also evaluating the mean from the same data, right? So if we evaluate the mean from the same data, all 6 observations are not because one observation is used basically for the evaluation. This is called a degree of freedom concept, right? So if you are evaluating some other statistics, right, it basically lose 1 degree of freedom. Okay, because whenever you have mean, right, and you have this any 5 values, so you can uniquely get the 6 values, right? There should not be any problem. If we have, suppose here we have 6 values and you have a mean as 3.837283, right? So anyone can give any 4 values, and you can very easily get an idea about, you can very easily calculate the 6th value, right? Sorry, here we have 6 value, right? And then mean. Suppose you have a mean and any 5 values, okay, any 5. So you can use the mean and you can get, and you can calculate the 6 values uniquely. So that's why I don't have to use 6 here. I'll have to use 5 because 1 degree of freedom is lost because of this mean evaluation, because I'm evaluating the mean using the same data X. Okay, so this is some kinds of sophistication, right? So you don't have to worry about this part, right? You just have to remember that because we are evaluating the mean, right, within the same data, that's why we not have to divide here by 6. We'll have to divide one less, and that is 5. Okay, then again here a bunch of other example. So I'll pause here on this calculation part. Any question, anybody? Okay, similarly we can do the square root. This is again a function I cover at the top. The square root, this is standard deviation, right? Sometimes we'll have to evaluate the variance. Variance is what? This is just the square of a standard deviation. Yeah, 19.92, right? So here it will provide the variance, right? And variance always have a unit in unit square. For example, centimeter square. If the values these values are in centimeter, so variance will be in a centimeter square. That's why we cannot compare the variance with the individual values because unit is not same. Okay, that's why we prefer standard deviation in all this clinical trial table, not the variance. Okay, because in the case of variance we may have a difference. Obviously we will have a differences in the unit, right? And we cannot cross compare the values quantitatively. Okay, so that's why we'll prefer always standard deviation. Okay, although these two quantities are related. Then again here another vector and range. As name suggests, it will extract the mean and minimum and maximum values, right, for a numeric vector x. Then quartile, it will basically split the data in 4 equal halves. What this means, so here we have a 1, 2, 4, 5, 7. Okay, so let me open a new page. Okay, so we have here 1, then 2, 4, 5, and 7. Right, this was the value we have here. 1, 2, 4, 5, 7. Okay, then I'm evaluating here a quartile. What this quartile does is basically split these values in 4 equal halves. Okay, so first of all we'll evaluate the median. Median is just the median values, so this is our median because 4 is the value, right? Below that we just have 2 data point, above that we have 2 data point. This is our median. Okay, then what we can do, we can further split this whole thing, right? This whole thing to half, right? We can further split this whole thing in half, right? And here q1, this will be our q1, this is our q2, and this is our q3, and q4 is at the very end, right? So q1 is the quartile, the values below that we have 25% of the data. What this means, when I say median, it will basically have 50% of the data here on the left hand side, 50% of data on the right hand side, right? So if we divide this 50%, right, further, so we'll have 25% of the data here, 25% of data here. Okay, again 25% data here, 25% of data here. So if you notice this q1 is the value. Below that we just have how many percentage of data? We just have a 25% of the data. Okay, here q2 is same as median because it will split the data in 2 equal halves. So here this is below that we have 50% of the data, and above that we have 50% of data. q3 is a value. Below that how many percentage of data we have? 50 50 25 25 50, and then again 25. That means total 75% of the data is below that point, q3. And q4 is the last one where we have all 100% of the data is below that number. Okay, so if we evaluate the quantiles, it can give a whole lot of idea about the values, how values are scattered. If we have deviation, if we have a large spread, right, between Q1 and Q3, that means we have data that have a whole lot of values that is there inside this Q1 and Q2. If you have a equal spread, that means data are a homogeneous kind. That means data are spread across all different possible points. Okay, so this is the way we can get an idea about the spread of the data. So quantile, range, standard deviation, variance, then again here quantile, right? These are a measure of position. So here we are not concerned about the values, actual values, although we are utilizing at the end, but we are more concerned about the position of the thing, right? Again, here I can also include median. Right, these are the basically a measure, and if we just include these four, right, this range, standard deviation, variance, and quantile, these are a measure of spread. Sorry, I'm writing with this will give an idea about the variability and spread, how data are spread across different data point. Okay, this is also another terminology, a variance, measure of variation, okay, or measure of dispersion, right? There are other quantities we can evaluate, the coefficients, right? Coefficient of variations, right? And those are basically unitless quantity. So that is not in part, right? So as a programmer, we don't have to worry about those aspects because those are basically statistical aspects, right? But these, we should have some idea, right, how this works. Okay, so I'll pause here. Any question on this before I go to the next part? Hope this is clear to everyone. Okay, there are two other quantity here. You can have IQR. IQR is nothing but interquartile. I guess someone is trying to speak. Yeah, please go ahead.
Yeah, p-val basically like proc means procedure whatever does the statistics. All we can with functions in our program.
Yeah, so here we don't have procedure as such. We do have procedure. There is a package SAS, right? I'll show you if time permits at the very end after completion of the thing. It will basically mimic the thing how we write in SAS. We have proc underscore means that will do the similar kinds of result what proc means does in SAS, right? So I'll show you that. But here we have a separate function, and we can evaluate.
But here, no need of using procedure. Only functions can we can handle by the functions.
Correct,
right?
correct. Yeah.
The p-value.
P-value part, we have a dedicated function. It depends which data you're using, right? Suppose you have a continuous data, you'll have to use different methods, right? And it also based on the inherent assumptions. You don't have to use directly, right? It should follow certain assumptions, right? So this is the way how this works. And we are planning to launch additional course, right, for the statistics as, right? So whatever the statistics or p-value evaluation that we do, right, as a programmer, I'll try to cover, but we are still in preparation stage. I will notify you. Okay,
Thanks.
Perfect. If you have interest, just let me know. We can cover 1 or 2 class at the very end. Okay, because we cannot cover everything, right? Because this is a very whole lot of topic, right? But I'll try to cover some basic p-value calculation using pair t-test, independent t-test, chi-square, Fisher, right? Klopper-Pearson interval.
Confidence intervals values.
Correct. Yeah. Okay. So here, okay, perfect. So we have another quantity that is called IQR. IQR is a quantity that basically provides an idea about the spread, and this is nothing but the difference of this third quartile and the fourth quartile. This is basically Q3 minus Q1. So you can just evaluate the difference, and that is your IQR. So let me validate. Okay, so I can evaluate the quantile, right? Here we just have to specify the statement, right? 0.25. This means first quantile. This is 2, right? Third, first quantile Q1 is 2, Q2 is 4, right? You can validate from here. It's the same, right? Q2 is 4, Q1 is here 2, right? Then again Q5, Q3 is 5, and Q4 is 7. And then IQR, this is basically a difference between third quartile and first quartile. So you can evaluate the difference. 5 minus 2, this is 3. Then again median and summary. Okay, so now I'll cover here the import and yeah. So for example, here we have various functions. So for example, I want to import a text file. So let me show you a text file. So we have here dummy_txt. This is a text file we have. Yeah, so we have here values 1, 2, 3, 4, 5 up to 6. These are ID. This is initials of the employee. This is date of joining, then gender and salary, right? The starting salary. And if you notice, we don't have here the variable name or column name. So suppose I want to import this. This is a text file. We can know. So you can notice this is txt file. So for importing any text file, what we have to do, you just have to use read.table function. Okay, then here you'll have to specify the file name and separator. If you notice this file, the values are separated with a space. We have a space here, we have a space here, right? So we'll have to specify the separator so that it can very easily handle the things, right? So I'm specifying separator is equal to space and header is equal to false, because this dummy_text file does not have a header or does not have the column name. That's why I'll have to specify that. So what this does, R will create a header for us. Okay, and here in the file name, we'll have to specify the file name along with the extension. So txt.txt is the text file extension. Okay, so let me run this. It will basically import, and by default it'll create a data frame for us, right? So AA is a data frame, and here we have the data. Yeah, and if you notice, it by default created v1, v2 up to v5 as a variable, right, for all the 5 columns, right? So this is the structure, how this works. Okay, so you can check the structure, right? This is data frame having 6 observations, 5 variable, right? And here we have all the variable and the respective data types. v1 is integer, v2 is character, then v3 is again character, v4 is character, v5 is integer. Okay, so let me use again the same function, and here what I'm doing, I'm just using this additional thing. Header is equal to true. That means I'm giving instruction to R that we have a header. Okay, but we don't have the header that in that file, right? So let me show you what this does. Here we have AA1, and if you notice, we have 1 observation less. Earlier we were having 6 observation, and this is the correct thing. Ideally here we also have to have 6 observations. So if I open this, there is a strange thing. What this does, it will basically sense the first record to an object variable name, right? It basically map the first record as a variable. Why? Because whenever I give this structure, right, this instruction is header is equal to true, what this does, it will map the first row as a variable, right? And how it does, so whenever we don't have a proper variable naming, for example, R cannot create the variable name with number, so it will add X, right, as a prefix. Here will not have any problem. This is AGKE, this is initials, so it can very easily map as it is. Again, for the date, these are again number. It cannot have a variable as a number, so that's why it added here X. And then for M, this is okay. And again for the number, it added X as a prefix. Okay, so here the problem is we are losing 1 record, and this is not ideal. So the moral of the story is, whenever we have a a file that you are importing, and that file does not have variables, so you'll have to specify here header is equal to false, so that R creates a header for us, right? And we should not have the problem of losing of information, right? So this is one thing. You can again check the structure and all, right? This is okay, but we are losing one observation. So that's why whenever we don't have the header, right, in the file that you are importing, you'll have to specify header is equal to false, so that R creates a header for us. Okay, so this is for text. We also have another text file that is separated with CSV, right? The comma separated file. So again, same function, read.table works here. Okay, read.table. Here I'm specifying directly the file name. This is a positional referencing. You can use file is equal to, but you can use without that also, right? And here I'm just writing separator is equal to comma, right? So if I run this, it will import. And here, if you notice, we have 6 observations. So by default, it basically creates the variable for us if the data does not have variable. Okay, and here we are not losing any information, and it is separating very well, right? Because the values are separated, right, in this file as right, with the comma. You notice we have a comma between the values. So that's why it is importing in that fashion. On the other hand, if we drop this separator is equal to comma, right? So in that case, what this does, if you try to map all the variable, right, just into us all the information in a single variable v1, right, it'll not recognize that these all are information that are coming from for a different columns, right? So separator is very much required for importing any files. Okay, so we'll have to specify separator based on the structuring of the data. Okay, so these are for text file. If you have separator as space, you'll have to specify separator is equal to space. If you have separator as comma, you'll have to specify, and for other also you can specify in the same way. Then the next thing is how to import the CSV file. This is very simple. You'll have to use read.csv. This is again a part of a base R function. Okay, and here you'll have to specify the file name. And if you notice one thing, I have not specify at any position at any places the location. Why? Because I already set the working directory here, right? And our all data is located at this position. You can notice. So that's why I don't have to specify the location of the file, right? So this is the benefit of setting the working directory. That's why I'm just writing the file name and I'm importing one by one. Yeah, and here we have the employee data. Check the structure. This is a CSV file. Okay, you can notice where it is. Yeah, this is comma Microsoft Excel comma separator values. All right, I imported this file. Again, you can use read Excel. For example, if you have an Excel file, right? So in that case, you'll have to use install this read Excel package, right? Then you'll have to load, and then you'll have to use read_excel function for importing the file. So let me show you. We have, I guess, yeah, here if you notice, this is an Excel file. So I can import from other locations. So you'll have to specify this way. This location does not exist because right now I'm using another laptop. So I'll just change this location, and this population file is right at this position. So I can just write this way and it'll import. Oh, sorry. I'll have to load this. Okay, so this package is not installed in my this current system. So I'll have to install using install.package function. This is very quick. Yeah, and then I can load. So installation you'll have to do a single time because I just formatted the system. That's why I have to install, right, all one by one. Okay, and here we have the POP. This is the Excel file that I imported. Okay, so this is the way. One thing is how it allocates the variable data type, right? So based on the structure, how it holds, it basically import, right? There is also one thing. For example, you have some values that is stored as number, and there are a few error where we have maybe values stored as character. So it will convert all things into a character data type just to accommodate, right? If you recall at the very beginning, so implicit coercion. So it follows that principle, and it'll try to accommodate the information, and it converts all variable into a character data type. Okay, this is one thing.
Ranjit, one small question.
Yeah, please.
Like as we have the limitation to import the data from Excel, right? In the SAS. So here do we have a limitation, or we can like, import any large file from the
Yeah,
Excel?
we can import any large file. There should not be any problem. So far, I
But because
imported.
in SAS in SAS in general we will encounter some issues while importing
Yeah,
data
so
if we have the
correct. I don't think, because I have not faced any issue while importing any large Excel file, right? So maybe you can try. It depends also on the
I
file and the system configuration. Sometimes, right? It
in
basically
SAS
slows
in
down.
general I face a lot of issues during the import.
Yeah, so
So
maybe you
I'm
can
just
try with
checking
your
that.
system. Yeah, you can try with your system and just
Yeah.
let me know. I'll show you some other resolution.
Okay, fine, sure.
Perfect. Then again, here,
So,
yeah, please. Right.
so in case we have 2 or 3 sheets in Excel, then it will import all sheet all together, or one
Yeah,
sheet
that's
in one
very
go.
good question. Yeah, that's really import the first seat, the first one, right? But
Only
yeah, here I guess we should have some way of specifying the sheet. I'm not able to recall exactly, but we should have sheet, I guess. Yeah, you can notice we can specify the sheet number,
okay.
and it will import a particular sheet that you specify. Otherwise, by default, it basically import the first one. Okay.
Is there any method we can import all the sheets all together? Like we
Yeah.
can convert to data set, like,
Yeah, so you have to use a function. You can just use you can put this whole thing inside the function, right? And you can
okay.
change the seat 1, seat 2, and whatever the name we have, right? You can change one by one, and it will basically update and change.
By applying loops and all.
Correct.
Okay.
Yeah.
Okay.
Try this, or let me know. I'll do that later. Okay. Just try it
Okay.
first. Okay.
Okay.
Any follow-up question, anybody? Because we are.
Hi, Ranjit. Do we have like range option?
Yeah. So I guess I'm not able to recall exactly. We should have somewhere. We can specify. I guess I'm not able to recall exactly. Maybe we can check this function read underscore Excel. Okay.
Okay.
Yeah. Anybody any additional question? Okay, so I'll cover very quickly because we don't have sufficient time, right? And here, this is an additional package. This is advanced package. It's created by Hardly Welcome. This is a very prominent, right, developer in our space, right? This package basically provides some faster, right, or efficient way of importing large files. So this package have similar kinds of function instead of dot, right? So whatever the function that is coming from this base are, that have dot in between, right? Read.table, read.csv. But the function that is coming from this readr package, that just have underscore inside. Okay, so let me load this package and I'll import. So same function, read underscore, just a difference underscore, right? And same way you can import the CSV file or any other file. This readr does not have a function for importing the Excel file, right? So for that, you'll have to use anyhow this read Excel package, right? Because Excel has some additional inherent structure. That's why that was not incorporated in readr package, right? But this can import file very quickly and very easily. Okay. Then here we have additional feature of specifying the column type. For example, I want to keep the first column as numeric, so I can use N. I want to keep second column as character, so I can use C. Anyhow, we cannot convert this character into numeric. So, but for numbers, we can have that possibility. We can store this number into character or numeric, right? So that's why I'm specifying. And the last two column, the column of sex, this is also, we don't have any other way, right? Except storing as a character, but last the salary I can store it in character. So we can specify, and it readily converts into that into the specified data type, right? So N is for numeric, C is for character. And here, if you notice the difference, earlier Sally was dbil. Dbil stands for double, right? CHER stands for character. And here, if you notice the difference, this is character. And this is not a truncation because we don't have space. That's why it is basically just showing the integer component, right? But whenever you convert this into character, we'll have a complete thing. Okay. So the next thing is how can extract a particular rows and column. You'll have to specify first is for the row space, second is for the column, right? You can specify and you can extract a particular column. So one is this, it will basically extract the first column. If you use here 2, it will extract the second column, that is a column of name. Okay, then suppose I want to extract the first row, first column, so I can use 1, 1, and it will basically provide this 1, right? So this is a row 1, row 2, row 3, right? And here we have a column 1, column 2, column 3, column 4, column 5, right? This is the way how it's works. You can also extract the call names. It will basically have the variable name here. Okay, suppose I want to extract the salary column, right? So what I can do, I can just write salary. This will fail, okay, because there is no object here in the global environment with the name salary. So that means this is not the ideal way of extracting any variable from a data frame. So for that, you'll have to use employee, $symbol, and salary. So I can extract that column from the data frame, and then I can do any kinds of mathematical operation, right? You can add, subtract, whatever. I'll basically update here based on the number that we do, right? The next thing is sorting. So this is an old structure we generally don't use, but I'm covering because I don't want to miss anything. So this is the way how this sorts in the base R way. Okay, you'll have to use a data frame name here. Then you can specify the order inside this big bracket, and then you'll have to specify the variable name. Okay, so suppose I want to sort with the salary, and at the very end we'll have to use a decreasing is equal to true and decreasing is equal to false. Suppose you want to sort in ascending order, so you'll have to use a decreasing is equal to false, otherwise it'll sort in descending order. So let me show you. So it will basically use the column of salary and sorting in a descending order, because I use a decreasing is equal to true. If you use decreasing is equal to false, in that case it will sort in ascending order. So we can have here. This is slightly complex structure. I'll show you the deployer way. This is very easy. You can check other structure, right? Other way, other line chunk, right? I'll use deployer, and here suppose I want to sort with the salary. So what I have to do, I have to use arrange function. Here I'll have to specify the data frame name and then salary. So it will basically sort with salary in ascending order. You notice smaller to right, bigger. Suppose I want to sort in descending order. So what I have to do, I just have to add this additional function DESC, right, on a salary. So it will basically sort this employee data descending of salary and ascending of age, right? You can verify. So this is a much clean, right, and efficient structure, right? If you try to compare using this benchmark functionality, the deployer are always efficient, and the structuring is also simple. Here we'll have to use this big bracket. Anyhow, these are the base R way of sorting the thing, right? So you'll have to have some idea how this works, right, and how we have to use, but we generally use this advanced R way of sorting the file. Okay, I'll pause here because I'm going very fast. Any question?
Ranjit, could you please scroll up?
Sorry?
Could you please scroll up? Just scroll up. I just want to have a quick question for read.csv. If you can observe that line 226 and 221, in 226 you have used in 221 you have used this file equal to employee, that file name, but
correct,
here you didn't use it. Will it work like that?
Yeah, it's work. There is no issue, because this is called a implicit expression or exact referencing, where we are writing the exact function along with the argument, right? So this is the keyword of the function read_csv,
yes,
and here we are specifying the path along file name along with the extension. I can directly use this work. There is no issue. Okay. But I recommend whenever, because you are at the very beginning, right? So I recommend try to use each and every keyword. I just want to showcase that without the keyword file, it works. There is no problem.
No, thank you.
Perfect. Yeah, no worries. Anybody, any question?
Hi, Ranjit.
Yeah.
At 226 line number, we are using R type equals to NCC,
Correct.
that character type. We have very few columns, so we are able to specify.
Correct.
If we have large number of columns, means huge data.
Correct.
Any option do we have to?
No, we don't have any other option. What you can do, you can extract the data type. For example, you can use a str function, and here we have, and you can create a data frame out of that, and you can extract this data type. You'll have to specify these manually. There is no.
It will be like a very tough job, right?
Correct. Yeah. So what you can do
for efficiency.
Yeah, this is the structure. There is no other way of specifying these, right? So we'll have to anyhow have to have understanding, right? So we should have understanding which variable you want to keep as character, which you want to keep as a numeric. Yeah, you'll have to use either this. There is no other way.
And here there is no like a database type DBMS equals to
No, we don't have any. Yes. No. So because in SAS it uses a particular database management system for importing a file, right? So they created a SAS in a different way, right? Here everything is utilizing the base R functionality, right? So we don't have to rely on any other database management system for importing a certain files. The functions are inherent built in inside the base R. So that's why we don't have to specify any other structure. Okay.
Okay.
Yeah.
Okay. Thank you.
And also we'll have to keep in mind. So this is just maybe kinds of thoughts. So SAS and R are two different programming languages. So there are similarities, but those are not same, right? So we'll have to be very careful, right? We cannot compare each and everything, and we should not think that we should not have this functionality here, right? Because each programming language has some additional benefit, right? This is absolutely free. You have access of a source code, right? You can manipulate, you can modify the source codes based on your requirement, okay? But we don't have that in SAS. So this is one thing. The other thing is, suppose you are working for freelancing, right? You are doing freelancing. You cannot buy a subscription of SAS, okay? But you can use all your work using R. You can do each and everything, right? Using R with the same accuracy, right? So these are some advantages we have. Although these two programming languages are different, conceptually also these are different. Right? SAS works in a row-wise fashion. R evaluates in column-wise fashion. It tried to evaluate one column, right, at a time, then second column, then third column, right? So at the internal mechanism level, right, both are completely different languages, but although we have similarities, functions are very user friendly. For example, if you want to sort, right, you can use this arrange function. You don't have to remember anything. You'll have to specify the variable and it can sort, right? This structure is slightly complex, but here also we don't have to worry much because we don't have to remember the keyword, right? Ordering. And also the main important part is R is having very powerful tool, right, for data visualization aspects. Reporting is very simple, okay, as compared to the other programming. Okay, so these are some advantages, right? Okay, so there is one function and that is called file.choose. This allows us to choose file. Suppose I don't know which file I have to import, right? So I can use this function read._csv, right? And I can choose the file. So let me do that. So what this does, it will open an additional dialog box. Yeah, here, and then I can choose the CSV file. So this is very important. So because I use read_csv, so I must have to choose the CSV file. Otherwise, this will fail and not import. Okay, so this is successfully imported, right? And now we can perform other operations. We can extract, we can manipulate the column, right? We can extract the column names. Yeah, we can extract the variable and all. Okay, so these are the imports. Similarly, we have one additional function. This is called view. You can use this function with capital V. You'll have to be very careful. You have to use capital V. What this does, it will basically open this data frame in the editor window. Yeah, but you can achieve the same thing. You just have to click right on this data frame and it'll open here, right? But you can use the function also. Yeah, the next thing is how to export, right? So for exporting the file, you'll have to use a write_csv if you are creating a CSV file. For example, if you want to create again a CSV using this readr, so this is the functionality of a base R where we have dot. This is the functionality of a readr package. Okay, you'll have to specify first the file name, and then here you can specify the location where you want to store, also the this file, right, the file name with extension. Okay, so what I'll do, I'll just drop this whole thing so that it will basically store at the working directory location. So let me drop this whole thing. Yeah, so this is as exported underscore 10. So it should have here, right? This is the file. Then again, I can run the other thing. This is exported 12, and there we have. Then again, we can also create a data frame using table structure. This is similar to data frame, right? But it has some nice feature. You can create a data frame in row-wise fashion, right? In SAS, we generally write data, then we can write input, right? We can specify the variable type, then we can specify either data cards or data line, and we can specify the values. So this is called a row-wise creation of data. You can have structure, the same structure here, using the table structure. Table is a row-wise creation of data. This is a function that is a part of table package, right? And here we'll have to first specify the variable name, and then here we are specifying the values one by one. So the benefit of creating the row-wise data frame is you'll not miss anything, right? For example, if you create this way, you can have 8 values at the ID, you can have 7 at the name, because all have different length, right? So you'll have issue of missing something, right, if you use this structure table or a data frame. But if we use this row-wise creation of data, we'll not have that problem, because everything, each abbreviation is just one town, right? So you can very easily get an idea if you are missing anything, right? So this is a row-wise creation of data. And the other advantage of table, so whenever you create a table, it will provide here the information about the data type of a particular variable. It will not have that information in case of a data.frame function. Okay, although both are same, but here the table will have some additional feature. It will give an idea about the data type, and these are efficient as compared to the data.frame functionality, because data.frame is a part of base R, and these are a part of advanced R. Okay, similarly we can modify the column, we can convert the column into character, and we can create a new column here in this student data frame, right? So you can practice. Let me know if you have any question. Okay, the last part is the memory requirement. Okay, for example, if I print this student data, here we have total 4 columns, okay, where we have 2 character and 2 columns are of a double or a numeric type. Suppose I want to evaluate, right, how much memory we need for importing this small file student that have 8 rows and 4 variable. Okay, so the thumb rule is this is just a rough case. It also depends on the system configuration, whether you are using 32 bits system or 64-bit system, right? So this is a rough rule. For one character you need a 4 byte. For storing one numeric you need 8 byte. Okay, and then you just have to do a mathematical calculation. So here, how many rows we have? We have 8 rows. How many character variable we have? We have 2 character variable, and we have 2 numeric variables. So we just have to do calculation. So 8 into 2 into 4, this is the memory required, right? Byte required for storing a character variables, right, of length of row 8. Okay, this is the memory requirement for the numeric variable. You can just add these two, and here we have 192 byte. Okay, then I'll create it here as maybe as a synthetic example. You can think of data where with these many rows and 100 columns, and all 100 columns are of numeric type. So you can basically do here calculation, right? If all are numeric, so we need 1.6 10 to the power 10 byte. you can convert to KB, just dividing by 1024, because 1 KB is equal to 1024 byte, and this much byte we need. This much KB we need, right? So then we can convert to MB, further dividing by 1024, right? This much MB we need. So then further divided by 1024. So we need 24.90116 GB for importing the file that have these many rows, and all 100 columns are of numeric kind. Okay, you can add some complexity. Suppose I just need 5 columns. I don't need all 100 columns. So we can reduce the size, right? You can just change Y as 5. I'll have here a memory that is required is less than 1 GB, right? This is so this way we can reduce the size. And here I just gave another example where I'm adding 100 numeric columns and 120 character columns, right? So we can do the calculation, and here we need 23 GB, 23.8416 GB for importing the files that have these many rows, these many observations, 100 numeric columns, and 120 character column. So if you are importing these large files, right, with this with the system that have less RAM, less than this 23, so it basically fails. So you should have at least, maybe this is 23, so maybe you'll have slightly more, right? Because sometimes we also have to do some additional work, right, with the system. So we need at least maybe 25 GB of RAM space for importing this file. This is just a synthetic example, but we should not have this problem, right, for working with the clinical trial data. This is mainly for finance, right? But I just want to include this concept so that we'll not have any issue if we are importing any very big file in the size of petabyte or terabyte. Okay. So these are all I want to cover in this session. Sorry for the delay, right? So we have a few minutes late. Okay, so any question, thoughts, anything?
No,
okay, so just spend some time, just revisit the recording, because at the end I just covered this very quick. So let me know. Don't hesitate. Don't let me know if you have any question. I'll happy to answer. Okay. So that's all for the day.
Thank you.
Thank you, everyone.
Thank you.
Bye.
Thank you. Thank you.
Thank you, Sneha.
Thank you.
Thank you, Ranjit.
Thank you. Bye bye.